Okay, some people requested in their journals some of these topics, so here I am. All right, so when you divide imaginaries, you multiply by the conjugate to basically get rid of the I in the denominator. That's the goal. So the conjugate is exactly like this looks. So if it's -6 and 3i, the only difference is whatever sign's in the middle, you flip it. So if it's positive, you go to negative. If it's negative, you go to positive. So this is positive in the middle, so I'm going to go to negative. And we're just basically kind of like getting a common denominator, like 2/3, you multiply the top by 4 and the bottom by 4, and you get 8/12. You're just writing it in a similar way. So by doing this is really just number 1, multiplying by 1, just like as a kid you were multiplying by 1. So, but now we actually have to multiply it. All right. On the bottom, so in the denominator, when you do FOIL or do the box, the i's should cancel, and the I squared you can turn into a -1. So you should get a pretty number there. Okay, so I'll just do the box. -6 positive 3i, -6 -3i. Okay, so I'm going to do the box. That's what, a positive 36, -18i. What is that? Positive 18i. So you can see those are going to cancel. And then this is a -9i squared. Okay. So what's going to happen on these is they will always cancel. You'll get an I squared, which is a -1. So a -1 times a -9 is a positive 9. So you can deal with that too. And 9 plus 36, what is that? Is that 45? So you're actually going to get some wonderful integer there. Okay. It's all going to be beautiful. Now the top, probably not going to be beautiful, but it's usually going to be a imaginary numbers, which again typically have an a plus bi part. Okay, it could just have the bi part, right, if the a is 0. So you could end up with maybe like 5i over 45 and then simplify that, but usually you end up with a binomial looking imaginary number. That's more typical. So I'm going to go ahead and do the box on that. So I'm not expecting, you know, just to get a nice little integer for this. I'm expecting to get something in that form. All right, so multiply, you get -24. Multiply, you get -12i. Multiply, you get, is that another -12i, but for a different reason, and -6i squared. Okay, let me double check. That looks okay. That looks okay, and that. Okay, so the difference is these don't cancel because they're not opposites, right? They're not, you know, x plus 8, x minus 8, where you get x squared minus 64. It's not the thing that gives you the difference of 2 squares. So here, this can turn into a number though. So -1 times a -6, that's going to be a positive 6. Okay. So -24 and a positive 6, I think that's a -18, but it's late in the day, so who knows? You can keep me honest. -12, -12, -24i. Okay. So see how I wasn't expecting this to be pretty. I was expecting it something like that. So -18 minus 24i. Now, as far as simplifying, it looks like 3 divides into all these. So if you can divide all these, I'm going to simplify by dividing it by 3. So I get what? -6, divide that by 3. This is a -8, divide by 3. And this is what? 15. Okay. And you might say these two are even. Yeah, but this isn't. So it has to be all 3. So I divide this by 3, this by 3, and that by 3. Now, this is, you know, this is okay. Sometimes if they want it separate, then you could do -6 over 15. And what is that? -8i over 15. And, you know, that's okay too. But notice then these do simplify, because if I put them together, then it's like, oh yeah, I could divide them both by 3. Okay. So if you, you know, leave it like this, you can't really simplify because all 3 have to have in common. But if you divide it into pieces, suddenly you can do that. So what is it? That'd be a -2 and what? Fifths minus 8/15ths. I run out of space there. All right. So, you know, so either way, I'm okay with that. I'm okay with this, whatever you want to do. All right. Let's look at the vertex situation. So if I ask you, okay, we got to separate these. If someone asks you for an equation of a line, they have a constant rate of change, right? They're a line. So like if you're walking up this line, that incline stays the same all the time, okay? So on these, you find the rate of change in y over change in x. Then remember you solve in 3 out of 4 into mx plus b. So you know input, you know your rate, you know your output, solve for b, and then you write your equation, whatever it might be. All right. Parabolas are not that, okay? Because remember, parabolas, if I'm walking on this, right, I'm going downhill. Here I'm, there's not, it's kind of level-ish, and then I start turning, I'm going uphill. Remember, they have a rate of change that changes all the time, right? It's only constant between 2 points. But, if I go between these 2 points, that secant line has a different slope than between these 2 points, okay? That's why we find the secant line. So this has a different format. There is no slope, okay? Only if you're finding a secant line, because lines have slope. So how do you do these? Well, on these, what you do is you do the x plus or minus whatever your shift is, and then plus or minus, and that's squared, plus or minus whatever your y shift is. So remember, your shift is your vertex, okay? So on these, we call it vertex form. So there's some coefficient. Now, the vertex is 3. Remember, your shift on your x is always opposite of what it says. So that's going to be minus 3 squared. The shift on the output is what it says. So minus 4. And so that is kind of the shell of what I have, okay? Then what you do on these, kind of similar to here. See how you sub in to solve? Well, yeah, once you get kind of the format, then again, you're going to put in input and output. There is no slope because constantly different stuff is going on all the time, constantly changing. But there is a coefficient which, remember, determines if it's skinny or kind of wide. So I'm going to sub in my input and output, order of operations, and be super careful. Let me grab a highlighter here. Come on, Julie. All right. This is glued together, okay? So that's glued together, and that minus 4 is separate. So you add the 4. A negative 2 times a negative 2 is what? A positive 4. Divide by 4, divide by 4. A is a negative, what, half? Okay, so this one's going to be a little wider. So then you come over here and you write your function or your formula, whatever, negative half, the vertex, again, opposite on the x, exactly as it is. And don't forget the squared, because if you don't put the squared, then it's linear again, and we want it to curve, okay? So this is what we have. Okay, now you could check it on decimals or do that. As far as graphing these things, okay, what I would do is I have 3, negative 4. That's my vertex, okay? I know this is actually going down because it's reflected. So I'm going to focus, kind of my areas down here. Hopefully I have enough tick marks. So I might want to come over here, 1, 2, 3, and sub in 4 to see where it goes. All right, so let's sub in 4. If my input is 4, okay, looks like a fraction, and I'm like, I'm not feeling fractions tonight. I'm going to skip it, okay? Because you have the power to pick the points, right? There's infinite many points. Pick wisely. Pick nice ones. Okay, what's 5 minus 3 is what? 2. 2 squared is 4. That'd be a negative 2, negative 6. Now, again, no one said you had to do this. I don't know what I did with my calculator. It is somewhere here. Maybe I'll just use decimals. All right. But again, you do not have to do order of operations, okay? Just get on your calculator. So what did I sub in? 5. Okay, so I'm going to have negative half. And again, always a good idea to put anything negative in parentheses. So I have negative half. Where is it? Okay. And then what? X minus, okay, so I'm subbing in 5. So just put parentheses 5 minus 2, end of parentheses, squared. And then minus what, 4? Okay, let's see. Don't want that guy there. All right, so that would be what? Nope, that's a minus 3. I'm like, we shouldn't be getting a decimal. Okay, that was minus 3. All right, so see how I get a negative 6? Whether I do it in my head or in a calculator, I get a negative 6. So at input of 5, so 1, 2, 3, 4, 5, I get an input of negative 6. So that's what, 2 over? Yeah, because this is at 3. So I went 2 over and down. So symmetry wise, I could go 2 over here at 1 and go 1, 2, 3, 4, 5, 6 down. Okay. And then I could graph that. The other thing is probably to get a y-intercept, okay, would be a good idea. So if I sub in 0, what do I get? 9. I'm going to get a fraction again. That's okay. I'm going to just do it on my calculator. So if I sub in 0, I'm going to have what? A 0 here? All right. So looks like the y-intercept, when I have an input of 0, my output's a negative 8.5. So I'm running out of space, but 1, 2, 3, 4, 5, 6, 7, 8.5. So that's only what, 1 over? So then 1 over for this guy is also going to be 8.5. But again, if you don't, if that whole symmetry thing you don't like, you can always sub an input into the formula and get output, and you don't have to do it yourself, okay? Let's see, I'm trying to think. We know the vertex of this axis of symmetry would be x equals 3 because that's where it's symmetrical around. And behavior, some of you missed this on the quiz, as it's kind of reflected bunny ears. So as x goes to positive infinity, my y is going to negative infinity on this one. And as x is going to negative infinity, so as x is going this way, my y is also going to negative infinity. Both, do you see how the y values are both going to negative infinity? The other thing on increasing and decreasing, some people missed this on the quiz. What's my vertex? 3, negative 4. Remember, you never use the y value when you do increasing, decreasing. I just crossed off so I don't screw up. So this guy's increasing from negative infinity to 3, and it's decreasing from 3 to infinity. So I'd watch that. I don't know what other, the person request, I just kind of help with graphing a little bit. I guess my best advice to graphing is plot the vertex, sub in points that don't give you decimals, right? And use a calculator to do the order of operations. Like you just type it in exactly as it is for input to get the output, just to save yourself making dumb mistakes on, please excuse my dear Aunt Sally. All right, hopefully that quick review video helps you. And then I will make one going over the more recent quiz that we took.